Chapter 9, Section 2, we're starting to talk about circles. Circles, we know from geometry very much about circles, but we need to look at them algebraically. So we are delving into the state standards again. Standard number 16. You know how the geometry of a conic section goes. Knowing something about asymptotes, foci, eccentricity, that, and the quadratic equation representing it. That's a goal for this entire chapter. And standard 17, we have to know them in two forms, standard form, and this form here is general form. You have to convert it from general form to standard form. What's a conic section? We'll explain this in more detail later, but it's a circle, ellipse, parabola, or hyperbola. We've taken a first look at parabolas, but now let's take our look at circles. And to give us a point of reference and a visual remembrance, if you remember from geometry, the definition of a circle, and for all the conic sections, we're going to start with our geometric definition. A circle is a set of all points in a plane that are a constant distance from a fixed point in that plane. That fixed point's the center of the circle. Constant distance is the radius of the circle. So there's only two things you really need to know about a circle. Where is its center and what is its radius? And here's algebraically what a circle looks like in standard form. The equation is x minus some number h quantity squared plus y minus some number k quantity squared equals r squared. Now the center of the circle we find by hk. Just like we did with parabolas. If there is a number inside parentheses, we take the opposite of it. So in the formula it's minus h, but the center is positive h, that's the x value of the center. In the formula it's minus k, we take the opposite of that, it's positive k for the center of my circle's y value. Now that equals r squared, so be careful about this. This number here is not my radius is r. So whatever that number is, I need to obviously take its square root. And let's do that first going backwards and then going forwards. So example 1 goes backwards. Says they got a circle with this center, negative 3, 2, radius 3. Find the equation. So we're going to put these numbers back into this formula, and that will give us the equation. So h is negative 3, k is positive 2, r is 3. Substitute those in the formula. X minus h, negative 3, quantity squared, plus y minus k, quantity squared, equals r squared. Very simply, when you're subtracting a negative, that's positive, so that's x plus 3 quantity squared, plus y minus 2 quantity squared, equals 3 squared, which is 9. So they wanted the equation in standard form, and there it is in standard form. So that's fairly simple going backwards. What we need to do is go forwards, find some information about the circle, and graph it. So on the tests, if we take them on the computer, obviously you can't draw the graph on the computer. I could have several graphs and you can choose one multiple choice. But we're going to need to answer questions about circles and parabolas and ellipses and hyperbolas first, but also be able to graph. So here's our equation of a circle in standard form. X minus 2 quantity squared plus y plus 3 quantity squared is 16. Find the center of the radius and then graph. So the center. If a number is in parentheses with a variable, we are going to take the opposite of it. Now whether it's a parabola, circle, ellipse, hyperbola, if it's in parentheses, take the opposite of it. So opposite of negative 2 is positive 2. Opposite of positive 3 is negative 3. So that's h and k. The center of my circle is 2, negative 3. The square root of this number by itself is my radius, 4. So that's answering the questions. Next step is now to graph it. So let's start by plotting the center, 2, negative 3. By the way, obviously then for homework, a compass will be helpful. Not the kind of compass that tells you north, south, east, and west, but the kind you can open and use to graph. So now what we want to do is put the sharp point of our compass on the center. Open our compass 4 grid units wide. Put the sharp point at the center. Take that compass for a spin till we get our nice little circle, which is, there we go, which is now officially showing up on the screen. So I open my virtual compass to a radius of 4, took it for a spin around the center, and that's all there is to know about circles in standard form. Find the center, find the radius, plot the center, open your compass the radius width, take it for a spin, you've got your graph. Now that we've mastered circles in standard form, let's take a look at a circle in general form. Now actually, this formula is a little misleading, so let me clarify for you. This formula, you are going to see this formula for circles in standard form, general form, parabolas in general form, ellipses in general form, hyperbolas in general form. When you have everything on one side and 0 on the other side, how are we going to know if it's a circle, parabola, ellipse, or hyperbola? Because this formula we start with is identical. And the way to do that is you're going to find some criteria in that formula. So for a circle, the coefficient of x squared, which we're calling capital A, coefficient of y squared, which we're calling capital B, they must be the exact same number, exact same sign. They could both be positive 1, they could both be negative 1. They could both be positive 3/2, they could both be negative the square root of 3, although we'll give you nicer numbers than that. But they must be the same number. So if you're looking at something that looks like this, everything on one side, 0 on the other side, if the coefficient of x squared, the coefficient of y squared are the same number, same sign, you have a circle. So what we're going to do is take a look at a circle in general form. X squared plus y squared plus 8x minus 2y plus 15 equals 0. Everything's on one side, 0's on the other side. It's something in general form. Now, obviously, you know it's a circle because we're talking about circles. But let's just take a look. This says 1x squared plus 1y squared. Therefore, they are the same coefficient, same sign, both positive. It's a circle. Our job now is to take it from general form and put it into standard form. So let's get an x family reunion going. Let's get all the x's together. X squared plus 8x. Let's get the y family reunion going. Group the y's together. So y squared minus 2y. And just like we did completing the square with parabolas or with solving quadratic equations, take the constant, move it to the other side. So I subtracted 15 from both sides. Now I left room here, because we have to complete the square for x, we have to complete the square for y. Get to do it twice. You can only complete the square when the coefficient of the squared term is 1, and fortunately in this example they both are. So the questions we're going to ask is, for x, what will I add to the x parenthesis to make that a perfect square trinomial? Let me refresh your memory. We use the Texas two-step. Texas two steps that do two things involving the number 2 to the coefficient of x to the first power. So that's 8 in this case. Two things. We're going to take the 8, divide it by 2, which is 4. We're going to take that 4, raise it to the second power, or square it. That's 16. So I add a 16 in the parentheses on the left side of the equation. And be careful. Since there is no number, no coefficient in front of the parentheses, it's 1, I am really also adding a 16 to the other side of the equation. So don't forget the addition property of equality for equations. If you add something to one side, you need to add it to the other side so that they are the same and balanced. All right, we need to repeat that process, this time for the y family. Y squared minus 2y plus something. It has to be plus to be a perfect square trinomial from chapter 4. It's got to be a trinomial. Last one's got to be positive. First one's a perfect square. Last one's a perfect square. You take the square roots of the first and last, multiply, double it, you get the middle term. That's how we knew perfect square trinomial from chapter 4's lessons. All right, Texas 2 step to 2. Don't worry about the sign because it must be plus that you add here to make a perfect square trinomial. Two things to that 2, also involving the number 2. We're going to take that number 2, divide it by 2, which is 1. We're going to take that 1, raise it to the second power, or square it, which is 1. Since there is no coefficient in front of the parentheses, I really added 1 to the left side. Therefore, I must add 1 to the right side. And we're getting closer. Now what we need to do is factor these perfect square trinomials. So that factors is the square root of the first one, square root of the last one, sine of the middle one. So that's x plus 4 quantity squared. Square root of the first one, square root of the last one, sine of the middle one, that's y minus 1 quantity squared. 16 plus 1 is 17, minus 15 is 2. There's our circle in standard form. So we went from general to standard form. Now it's in standard form. We ask the question, what's the center? What's the radius? So the center, opposite of what's in parentheses with x, opposite of what's in parentheses with y. So that's negative 4 is the h value, positive 1 is the k value. The square root of this number is the radius. So that's the square root of 2. How do we graph that? Well, let's take a look. So let's get our graph paper ready. Let's look at the standard form portion of it. Let's plot our center. So that's negative 4, positive 1. And here's where we need our scientific calculators again. Square root of 2 is approximately 1.414. But 1.4 is close enough for this graph. So what you do is you take your compass, put the sharp point on the center, open your compass 1 and approximately 4/10 of a grid. Not quite half, 4/10 of a grid. So if we do that and plot that, we get our circles. So there's approximately a radius of 1.4. Take it for a spin, put the sharp point on the center, take it for a spin. There's our circle with a radius of 1.4. So for that, we take the circle from general form to standard form. Once it's in standard form, we know how to do everything else with it. All right, a couple more things we need to know about this in the state standards. And we'll talk about this a little bit more as the chapter progresses, not necessarily today. Circles, ellipses, parabolas, hyperbolas are called conic sections. If you take a right circular cone, in fact 2 of them, put them apex to apex where their bases are parallel, and you start slicing and dicing, and you can find that at this web page, and we'll look at that web page a little bit later, just not today when we summarize. You'll see how we get up with the shaped circles, ellipses, parabolas, and hyperbolas by slicing a cone. All right, now here's a couple of other differences. Ellipses, parabolas, hyperbolas have a point called a focus. That point is different from the center. For a circle, it has a focus, but it sits right on top of the center. So we know focus of a parabola, or we will soon, if we forgot. All right, so for a conic section, we're going to use C to represent the distance from the center to each focus. In a circle, since the center and the focus is the same, that distance C is equal to 0. And for conic sections, there's another thing we need to know called the eccentricity. We use a lowercase e to represent that. So for a circle, the eccentricity is the same as c, the distance from the center of the focus, divided by a. What's a? A is half the distance of the major axis of symmetry. In the case of the circle, we're talking about the radius. The axis of symmetry would be the diameter, half of that is the radius. So the formula for eccentricity, E, is c, the distance from the center to the focus, which is 0, over a, the radius in this case. And so 0 divided by a is 0. So what we'll need to know and memorize, beyond memorizing the formulas and everything else, is that the eccentricity of a circle is 0. What is eccentricity? Eccentricity describes the shape of a conic, measuring how much it curves and how much of that curve varies from a circle as a reference point. So since a circle is a circle, it varies none. It varies 0 from the circle. And I'm going to have this little chart on just about every lesson that we do on conic sections so that you can kind of refer and refresh. Right now we're just going to talk about the conic section circle. E is 0, the ratio is 0, the eccentricity is 0 for a circle. Later, as the year progresses, or as this chapter progresses, we'll talk about eccentricity for ellipse, parabola, hyperbola. Now, the formulas will be more important. I will not ask you how we derive the eccentricity. All you will need to know that eccentricity of a circle is 0. I do ask that on a test. Eccentricity of a circle is 0. That's essentially all there is to know about circles as the conic sections from the algebraic point of view. Standard form, find the center, find the radius, graph it. General form, put it in standard form, find the center, radius, graph it. And what's its eccentricity, which is 0.